Hi, this is the last moment revision of work energy power. So, when a force displaces an object through some distance in the direction of force, the work is said to be done. For example, consider a block of mass m, and if we try to move a object, the displacement traveled by the object while pushing and the force, the multiplication of both of these quantity will give us the work done. So work done by the force is equals to force into displacement. The SI unit of work is Newton. Work is a scalar quantity because both the force and the displacement are the vector quantities, and the dot product of the both of the vector quantities will give us a scalar quantity. That is why work done is a scalar quantity. Positive work. A work is said to be positive if the applied force is in the direction of displacement. For example, a horse pulling a cart on a leveled straight road. Since both the horse and the cart are moving in a particular direction without any frictional force acting on them, so they will be working as a positive work. Next example, a child pulling a toy with a string in a straight line on a floor does a positive work because both the child and the toy are moving in a particular direction with respect to each other. That is why the work is said to be positive. If they are moving opposite towards each other, then we will say the negative work has to be done. So if the applied force is in direction opposite to that of the displacement, we will say the negative work is being done. Examples. Number 1. The work done by a brakes in stopping the running vehicles. Consider an example. If a running vehicle is coming towards a child standing in front of it, the amount of force he will apply to stop the car will be opposite to the way in which the vehicle will be coming towards it. That is why the negative work is being done. Next example is the work done by the friction on in sliding on a rough surface. Since, as I have told you, the friction will always act opposite to the direction of motions. So, on sliding the object, the frictional force will act as a opposite. That is why a negative work is said to be done. The next we have is a zero work. So, if the angle between the force and the displacement is 90 degree or the displacement is zero, we will say the zero work is being done. Example, the work done in pushing a rigid wall is zero because the displacement of wall is zero. As it is obvious, like if a person is trying to push a standing wall, the work done by it will be zero because the wall is not displacing anywhere, it is standing still. So the displacement is zero will correspondingly give the work done to be zero. The work done by a colleague carrying a load on his head standing on a platform is zero. As it is obvious, the displacement by a person who is standing on a platform will be zero even if it is having a lot of weight on his head, but the displacement is zero will give us the work done to be zero. Energy. The capacity of the doing work is called energy. How much effort is required to or to move a object is known as energy. Example number 1. It is difficult to stop a running vehicle with hand because the running vehicle is in motion, and that is why it is possessing some energy. So greater effort has to be required to stop a running vehicle. That means much energy is required to stop a vehicle. Kinetic energy. Kinetic energy is actually obtained due to the motion of an object. So if an object is in motion, we will say it is possessing a kinetic energy. Example number 1. Speeding car has a kinetic energy. As it is obvious, the car is in motion, it will obviously attain a kinetic energy. Next example of which we have is an athlete has a kinetic energy because the athlete is in motion. The formula of kinetic energy is equals to half mv square. Since it is already about object, that is why it will have some mass, and it is in motion, that is why it will have some velocity. So kinetic energy is equals to mass into velocity square divided by 2. The relationship between the momentum and the kinetic energy is denoted by P is equals to under root of 2ke. Potential energy. It is the energy that is obtained due to the position of object by shape or size. So, if an object is at some position, regardless of its shape and size, we will say it is possessing a potential energy. For example, a stretch bow has a potential energy because while stretching a bow by an archer, it will hold the stretcher on his arms. That is why it is actually at a distance from the ground, possessing a potential energy. The next we have water stored in a dam has a potential energy because at certain height the water will be stored from the ground. That is why it is possessing a potential energy. Law of conservation of energy, which states that total mechanical energy, that is the sum of kinetic and the potential energy, is remain constant, and the proof of which is very important for the CBC point of view. That is why I have included in the PPT. So consider a body of mass m at a point A, which is at a height from a ground h. So at a point A, since it is at initially stage, that is why initial velocity will be 0, and putting in the formula of kinetic energy half mv square, where v is 0, will give us kinetic energy will be 0. Since it is at height h from ground reference, it will have some potential energy which is given by Pe is equals to mgh. G is the gravitational force and h is the distance that is being covering from the ground. So total energy, that will be the kinetic plus potential energy. Putting the values, we will get the total energy is equals to mgh. Now, during the fall, after moving a distance x from A, the body has reached a point B. Now it is at point B, it will definitely possess some kinetic energy because it has traveled some path. So, in order to calculate the final velocity, while reaching at point B, we use the equation v square is equals to u square plus 2as. As we know, the initial velocity is 0, so v square is equals to 2ax. Putting in the equation of kinetic energy, instead of v square, we will put 2gx and we get the kinetic energy as 2g. Kinetic energy is mgx. The potential energy will be mgh minus x. Since we will subtract the final value minus the initial value, the final value is h and the initial value is x. So substituting the value, we will get the total energy is equals to potential plus kinetic energy, which is equals to mgh, which is actually the same as at a point A. Now at point C, since the potential energy at that point will be 0 because the body has reached the bottom level, and potential energy is all about certain distance traveled from the ground. Since the distance will be 0, so the potential energy will be 0. Now using the equation of v square is equals to u square plus 2ax and obtaining the value of final velocity, we will get v square is equals to 2gh. This will be 2gh because the total distance we will take while reaching from point A to point C, and that is noted by h. And the kinetic energy is equals to E of x is equals to half mv square. Putting the same value as we have put in the case of A, now v square is equals to 2gh and we will get answer is equals to mgh. Now energy at C will also be same as at the point A and B, which proves that total conservation of energy remains constant in an isolated medium. Next we have power. It is defined as rate of doing work. How much work a body is doing while with respect to a time is denoted by power. So power is equals to work per unit time. As we know, work is equals to force into displacement divided by time, and the displacement per unit time will give us the velocity. So we can write the power is equals to force into velocity, where force is denoted by F and V is the velocity. The SI unit of power is joule per second. Next we have energy transformation, which states that energy can be transformed from one form to another. So reservoir of a dam has a potential energy because it is at certain distance, that is why it is possessing the potential energy. Falling water has a kinetic energy because the water is in motion, that is why it is obtaining a kinetic energy. Turbine has a mechanical energy because it is rotating as well as it is generating something, so it will have both. the potential as well as kinetic energy. The generator, as we know, that is meant for generating the electrical energy. We have some examples for it as well. The electrical lamp will convert the electrical energy into light energy. Heater converts electrical energy into heat energy, which actually proves that the energy can be transformed from one form to another. Thank you.